Okay. All right. So we're just trying to finish this thing. So we started this yesterday and the traces. So one thing that we're going to need to know is so trace width is actually going to be important here. So wait, why don't we selection filter all items, tracks. Uh, I think it's just that. I thought we ran the. Oh no, yeah. You know what? The auto. Okay. So here's what we're going to do. Is this going to merge all of them? So that's tied together. This is tied together. So, I mean, okay, so the goal here is to just, the thing is, right now, this is actually not right because we need the FET. Okay, wait, oh, how are we going to do this? Oh my goodness. Wait, what I should have done is I should have, before I did the grid, okay, hmm. Okay, so wait, let me just make a little to-do list to figure out everything that we need to do in this stream. Okay, so we need to, um, find a NFET. Then we need to get the USB with correct trace width. Then we also need to test G photo 2. Um, then we need to um, figure out what is it called? MCDC2. Um, MCDC2 is going to be the Pico route. So this is the Pico. So I think what that amounts to is that we just have a couple of transistors on board. And then we need to figure out signal connections. It was recommending a ribbon cable. I kind of think a ribbon cable might be fine. I think okay, anyways, so we're gonna have to learn about more connectors. You know, if there's one story about PCB design, it's that you got to figure out your connectors. I'll be back. Okay, so what I realized is I don't actually have to route these in-betweens because the auto router, the only thing that's connected to this, if I highlight this, wait, what's going on? Why can't I? What the fuck is going on? I thought, if I select, why can't I select this? Oh, because of the filter, lol. LOL. Okay, so that is like that, but then if I do this, okay, wait. Um, oh no. Wait, that's super not right. That's not right at all. Okay. What? I think I know what to do. All right, let's delete this again. Or wait, we're gonna go here and copy this. I'm gonna paste it in here. And we're gonna delete all of this crap. Okay. Then we're gonna grab it, move it like right up here. Okay, this is R37. See these identifiers? This is stupid. Let's just start over. Let's just start over. Okay, so we need to add um this 120. I don't know why it doesn't find it because the phrase 120 is literally in there. 120. I don't know why it doesn't find that. That's so annoying. And does it have a value? Its value is its name, but that's fine. I don't really care about that. Okay, then we need this XL. Yeah, so it's this. Okay, sounds good. All right, so this is pretty much all we need, except we need some 5 volt. And I think I could just add, I think I don't even need this global label because these are just like special labels. So let's try to get good practice down, right? So instead of this, we can literally just do this. All right, so now we have like our block. Now we want to go 1, 2, 3, 4, 5. Okay. Then we want to take this, duplicate it. 1, 2, 3, 4, 5. And the thing is, like I would like if I were gonna try to like really learn KiCad, I would spend the time to figure out, okay, how can we actually automate this? I'd look into the Python API. But the thing is, I just don't care. I just don't care. And that's, I think, okay, so wait, here's the question though. We need to delete everything, right? Except for this, I think it's called is it called rule area? No, it's not a rule area. Zones? Maybe it's zones. Maybe it's other items? Bro, okay, wait, how do I see what part? Layer edge cuts, type drawing. So maybe graphics? Okay, there you go, graphics. So we can keep zones, other items. All right, so we delete this. Now, we don't want to do this, right? We want to like manually place footprints. So we just do A. Oh my God. Okay, wait. Preferences, manage footprint libraries. So again, we're going to remove all of this crap that I don't want. And then only use maybe oh my gosh. Okay. Software, bro. Software. I love software. All right, good. So now we have this. Now I should be able to add something. And what do we need? We need the DC in. Okay, we can just put that. Like, I don't know if we want to put it there because of the topology of this thing. Let's leave it there for right now. I mean, we're not even close to being done with this, so let's just leave it there. And then why is it a ref star star exactly? Oh my gosh, see, that's the thing. You don't want it to be a ref star star. You want it to be... But how do I add an individual? That's what I need to know. Wait. Oh, I didn't say KiCad. Hopefully it knows KiCad. Okay, at least it remembers I'm in KiCad 9. I low-key just feel like KiCad kind of sucks. It's like, dude, what the hell is going on here? Why was the last one no good? The last one was no good because, oh, you know what it was? Actually, I think there may be a route to... So okay, wait, let's copy this, make a hierarchical thing again. This is gonna be like R LED. Oh my god, thank you. Okay, so if we have one of these things, I don't want that. Okay, good, I can't delete it. Okay, whatever. So, wait. R LED, but it's not in here? Link. Okay, yeah, sure. But is it empty or not? It's not empty. That's so weird. Okay, okay, see how this is 28, though? But if we have this and we... How do we do the thing again? Auto place fields. Okay, that... I don't even know what that did. Alright, so we have this block with the labels on the thing. That's cool. Right, but then if we duplicate this, like 37, 28. So I don't understand why when we had multiple... I wish I could do a thing like in a bunch of other programs where I could just mute... I could just mute these. Like, I don't want to delete these because I just spent the time to make them, but I want them to be, like, ignored. Okay, let's do this. Oh my god, this is so freaking boring, dude. People that are like, yo, pivot to hardware. Yeah, you really want to pivot to hardware? Software is way better. Okay, so what happened? So, okay, let's just... What do I want to do here? I wish I could just hide these. Can I just like mute them? Attributes. Is there like an exclude from simulation, exclude from board? That sounds right. Okay, so now if we jump to the board, let me do this. Annotate. Updating PCB requires a fully annotated schematic. Scope, recurse into subsheets, reset existing annotations. Wait, what does that even mean? Okay, good. Is that good? I can't even tell. Wait, so we have 2 resistors and 2 things, and they have different identifiers. But the problem is when we, okay, like let's just say we select this, then we do tools, then we do the multi-channel. I think it's repeat layout, right? No, see, I don't. Select a reference rule. All right, so we probably should do that because that seems like the recommended way, and just figure out what repeat layout does. But I think the other way of doing it was this create array thing at Control T. Assign unique reference designators. So then I don't even know what the issue was because I feel like this is totally fine. Oh, but you know what it is though? It wasn't that, it was this. What is this? This is, so it doesn't update it updates the reference designator and then doesn't update the the net. It keeps the net the same. That's so ridiculous. All right, whatever. So okay. All right, hold on. Should we literally just do what that guy did in the video yesterday and just like look at the freaking um S expression version of this and then just see how it's placed and then just write Python code? Because let's see, there probably is a, wait, first off, exclude from board. Okay, yeah. So okay, so we learned about exclude from board. I'll write that down. Exclude from board. That's how you ignore it. But okay, because here's the difference. So let's delete everything. Then we're gonna go back to the schematic. Here we're gonna do this, exclude from board. Attributes, exclude from board. Then we're gonna go here, transform attributes, don't exclude from board. And we're gonna save this, jump over to the PCB, update, and then what we should see is, wait, wait. What is that? That sounds relevant. Normally, footprints are linked to their symbols via their unique IDs. Select this option only if you want to reset the footprint linkages based on their relink footprints to schematic symbols based on their Okay, wait, let's... Okay, wait, let's see what happens. Okay, so now, if we... See, this is right. But the thing about this is that it's impossible to place. So what I'm thinking is maybe we'll do this, and then we'll just look at the S expression. We need to make this a repo anyways, because I did end up finding out how to do this. This actually ended up being... someone on Discord told me is that you just do module RLED, and then you do this. You just say we have R120 is equal to, bro. Actually, let me just go to Discord because I forget exactly how it works. Because I just want to. I mean, it does not at all help me. It doesn't at all help me place them. Okay, so let's do this. Then yeah, so that's what it was. So then you make an array of group thingies, and then you can Jack 1 group thingy R120. Okay, so let's just copy this. Wait, actually, let's just do this. So LED equals new. There we go. So there we go. So that's what that is. Now we say RLEDs is equal to new RLED 36. Then for RLED in our LEDs, Jack 1 goes to RLED dot R120.1. Then RLED.R120.2 goes to RLED.LED.anode, and then RLED.LED.cathode. And then that should work. Why isn't that working? Oh, there we go. Okay. So this is the schematic. So now if we were to and I hate that it does this thing. It's like you got to kill these things every freaking time. It's so annoying. But build. So this should work. Okay, then we launch KiCad. And the placement of this is actually really nice because see, the pads are correct. Now, I think I actually really like this. This is really clean to me. So all right, so let's put a pin in that because I'll close this, but let's put a pin in this because where is the actual PCB? I think it's this. So the it doesn't generate a KiCad schematic, I guess. I guess it uses it directly builds a KiCad PCB expression. But so here, okay, we have all of our layers, the setup, net 0, I don't know what that is. Net 7, 3, I don't know what any of that is. Okay, then we have a footprint at. I don't know if we want to, we probably don't want to modify the footprint, right? At 0, 0, 0. Okay, at 0, 0, 0. Reference DC1. Hold on, can we? Oh, so wait, at reference DC1 layer. Okay, interesting. Property checksum at 0, 0, 0. Man, this X expression is wacky. Property. Okay, so props. We don't need the props, but what we want is attribute through hole. Okay. Then this is silk, 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 silk. Oh, this stuff is on the silk screen. Fab. But is that genuinely at 0, 0, 0? If we were to go to the... That's illuminator. Oh, I closed it, didn't I? Hold on. Okay, so let's do R1. Okay, if I look up for R1, okay, reference R1 at. Okay, so if we just change this. Wait, what is at? I thought at. Okay, wait, hold on. Where can I find the KiCad PCB SXper documentation? Like, what does at mean? I don't know what at means. Jesus. Okay. Bro, this thing takes so long. KiCad PCB SXper. Word file format. That sounds right. What the freak? What the freak? At 0, -10. So wait, if we hover over this, do we have an X? Okay, so this center point right here, 0. Okay, so all right, we just figured it out. It's like not that hard. So if we go to R11 at 10 minus, okay, great. So we're just going to basically, how do we, what's a good way? I mean, so I guess we want to do, so what point is this? Oh, and how do I make my grid? How do I change my grid? Was it like control 1 or something? It was like, oops, I just did something silly. Oh, alt 3, but alt, where can I just see the keyboard shortcuts? List hotkeys. Grid. Switch to next grid. Is that just N? Okay, so this makes it small. Okay, cool. So it's just N. So I don't know why there's like 2 lines there, because I would prefer to just do everything based off of 0, 0. Wait, 0, 0, which is here, but then it's like you can't really do that. But I'd say let's just do it off of 0, 0, so then I don't have to deal with any offsets in the code. So what we're gonna do is we're gonna go to the edge cuts, then we're gonna draw a rectangle, and it could be, wait, R. Okay, then we're gonna edit this. It's gonna start at 0, 0 by corner and size. Then this thing, we have yet to actually determine what the size of. Oh yeah, and then mounting holes. We need mounting holes. And then we're gonna need to figure out how we want okay, this is actually turning into a much more complicated thing than I want. I mean, I do want an enclosure for it. So the idea would be like top view. Top view, we have a square. Okay, this is like the, or maybe it's like a rectangle actually. Okay, then we have like mounting holes. The board is mounted there. Then we have a cutout here. So this is the barrel. This is the jack. And then we have the LEDs. And we have like all the power electronics. We have the like FET or something like that. Okay. And then the idea is that the board um I think let's just open up and see what we're doing here. Boring. But it'll be worth it in the end. It'll be so cool. So we have this plate holder and we try to fix it. I forget what we did there. Heat block, Euro rack. Is it in here? I kind of doubt. I forget where did I do it, you know? I could have sworn I did something. How do I hide this stupid crap? Heat block, Euro rack maybe. Maybe Euro rack. I think it's Euro rack actually. There's this. Maybe I got rid of this. Man, I spent so long on that. All right, fine. We'll just start over. So the stack up will be then like you have like, so this is like the top. This is top. Then you're basically gonna have an M3 bolt that goes through the board. So this is the board. Then this is gonna have like one of those things like this. And this will just be like whatever. So this is like a threaded. So I guess we do need to figure out the size of this thing, because okay. So S expert placement. I mean, I'm pretty sure that is there a well supported Python package to modify the S expression, or Actually, you know what? I'm gonna get some socks. Okay. Let's figure this out. Kai Utils. Newer. Oh. Schematic and layout. So wait. Okay, I think. Okay, so what we're gonna do is we're gonna make the um so obviously I'm not gonna just pip install it because I don't use pip anymore. So what we want to do is in here, let's just do this in here. So UV init dot or something. UV add, what is it called? KiCad skip. And then how do I open a, is it UV Python? Okay, so what I want to know is in UV Python packager, how do I open a REPL that has the environment depths that I've added? I swear. Oh wait, I'm on thinking. I actually want to switch because I can't keep waiting so much. So wait, I actually want to look at this one. This one's probably has more stars, but that psychogenic one actually looks pretty good. And it has more stars anyways. So I'm just going to use that one. There's UV run. Oh. The user wants to know how to open a REPL with the environment dependency, possibly with UV run Python. UV Python REPL. UV run Python. Import skip. Syntax warning. Okay, I don't know if that's. Okay, so it's UVX run, or it's UV run Python. Okay, so now how do I use? Oh, that's so sweet, bro. So how do I open a Lotus skip? That's schematic. What about, okay, skip dot PCB, and then we give it a file name, right? So then this is going to be in what? Hello, layout. Oh my god, I'm tripping. Layouts default dot KiCad PCB. None type object has no lambda s. What's wrong with this? Okay, so what if we go to the other one? Open folder. So this is going to be source KiCad illuminator. Open. uh, uh, bro, what? Ugh. My gosh. Okay. So, who makes SX data? SX data. Yeah, it's a generic S expression parser, but it's real. It's probably specific. I mean, because the thing is, not just I don't know. There's a lot of different ways to do S expression parsing. Because I remember my Rust S expression parser didn't actually handle because there was something that it didn't handle about KiCad's S expressions. So okay, so we're here. Now what we want to do is UV run Python. Now we want to import skip. Then we want to say PCB is equal to skip dot PC. Is it PCB? PCB. Um, illuminator dot KiCad PCB. Symbol has no object base chords. He doesn't. I mean, because the video he only showed how to mess with the PCB. Is there anything about the PCB? There's a PCB section. Maybe this just hasn't been updated to KiCad 9. Uh, I mean he hasn't been responding to this at all. But why is mine? I mean, it sounds like the S expression is malformed. Hold on. Now it's getting bright out. Let's go to light mode and toggle light mode. Okay, so symbol has no object base chords. The thing is, this parser is so crappy because it doesn't have any information on where the parsing went wrong. But let's see if we can just parse it as UV add SX data. Okay, so then how do I import it from loads dumps? Okay. All right, so let's just write we have a main.py. So say import skip from loads dumps. Then what we want to do is we want to say loads. Oh, okay, wait. So lol. Well, okay, wait, hold on. Isn't there a is that it? I think that's it actually. So S is equal to read file. Why does it think I'm doing a scheme? Okay, so it's going to be illuminator.kicad PCB. Okay, then we want to do loads. Sex is equal to loads S2 dump or print dumps Oh, okay. So it loads it into just a simple tree. That's cool. So wait, then we should be able to just print. Is there a pretty? I think I should just be able to do print. Now we should just be able to UV run. What is it called? UV. Oh, UV run main. Okay, so this was able to parse it. So then why uh am I getting errors? Okay, so now what we want to do is we want to do PCB is equal to skip.pcb. Okay, so this is the error. Symbol object has no attribute base chords. Does it say anything about the versions of KiCad that are supported? Because I wouldn't be surprised if the KiCad schema is has changed from, I don't know, because it was a major version. But we don't need it. We don't need any of this because we're gonna redo the CAD anyways. All right, let's see if so let's just do this. Is this, it does make a vemv, right? But it wraps vemv, so this, okay, so that's how we get that. So that fixes that, but um um let's just ask. Could it just be like that it, oh, maybe it's just not saved. Wait, let's just try it again. Never mind. Maybe I'll use the old one. I mean, I kind of wanted to use this new one, but all right, let's see if reading the schematic works. It's not that, it's schematic. Yeah, so that works. And we can do that in the REPL. Bro, I hate Python so much. Python's so stupid. I don't know how people put up with that. So what do we have? Okay, so what else do we have though? Lib symbols? I don't know what that means. Okay, cool. Symbol power, symbol power. DC, R. Okay, so these are like the... Yeah, okay. That's interesting. Looks like... Yeah, see? Oh, so it was, bro. So it was. Gosh. Looks like KiCad skip is choking on a newer FP text attribute that it doesn't recognize. Your traceback dies in footprint text.init where it expects a chord-bearing child but instead gets a bare symbol, an atom like unlocked hide. In KiCad 8 and 9 added standalone flags with open issues about parsing their PCBs. Oh, really? Wait, where's the issue to the PCB? Make PCB work? Okay, so it's known. Ugh, you gotta be joking, dude. Stepping through the debugger, I was able to get the PCB to work with V8 files. So, I see a PR that says it works on PCB V8, but were there additional changes to the in PCB V9 since I am on KiCad 9? Chord bearing child, but instead gets a bare symbol. KiCad 8 and 9 added standalone flags. Maybe we'll just try this. And then let's look at the documentation. I mean, I was kind of hoping to use skip, but I mean, skip is broken, so whatever we can do to get this thing to freaking work. Let's at least ask the question, but damn. I'm supposed to be designing my primers and ordering reagents, and then I mean, I guess it was a little naive of me to think that I could really design a PCB in a day. Board 2 file. Oh, no, that's not what I want. How do I read? Parse an already existing object. Do some changes and re-export. Okay, cool. So this is what we want. So now we're going to do... So what is the package actually called? Pip install what? utils. Okay, so uv add utils. Okay. I don't think I want to go down that route. I think I'm just going to try to use this one. Although they're both updated last year, dude. Man. Shit sucks. This sucks, dude. Oh my god. It's so annoying. All right, so let's okay. All right, so we can just do so let's this is all garbage. So we should be able to do PCB is equal to board dot from file PCB function file name. Okay. So wait, why don't we? Does this like update? Nice, dude. That's the sick thing about interpreted languages. Okay. So what I want to do, so which one are we in? We're in the actual, so we want to like modify. So PCB dot dimensions file path footprints. Let's do 1. Wow, that's even the first footprint. Library nickname easy to KCAD entry R0805. So let's see what's in here. So FP is equal to or let's do 0. FP dot entry name. Auto place cost. Oh, that's interesting. Clearance. Create new description. All right, what's the description? Okay. Position. Wait. What is the actual freaking name of this thing, man? Like, what is the reference designator? That's like the precise name for all of this stuff. Okay. For item and footprint graphic items. Oh, really? That's where the reference designator lives? Oh, okay. Wait, but let's see. Is there documentation for the other one? He just made a video about it. Okay, whatever. We don't care. We just wanna do this thing. So so we have an FP, right? So FP dot, how do we change the position? Adding vias, loading and adding a footprint. Footprint dot position is equal to position. Okay, let's do this. Let's paste it in here. FP dot. So wait. But how do I get the reference designator? Because what I want to know is when I'm looking at this thing, this is kind of the best way that I know. Because I don't know what the name of this thing is. This is a LED, right? FP dot entry name. So graphic items. How did he do this? If item dot type return. Wait. So hold on. Return item. Or reference graphic item. What? It's a none? Oh, well. It's a none. There was no reference? Text equals dollar reference. Hold on, we're probably talking about LED 1, right? Oh, okay. Ugh. This is psychotic. Seriously. So, what do we need to do? We need to, because we're going to have to update all of these positions, right? Or are they relative to something? I would assume that these things are relative. I mean, this seems like a relative thing, right? Okay, so whatever. Let's just try to move something. FP dot position equals position, and then is it gonna give me any help? Of course not. X equals 0, y equals 0. Let's just do this. Okay, then but does that, when I do that, boards.footprint.append, see, that's not what I want to do. I wanted to modify. But if, okay, wait, hold on. Let's just see if this works. So if I do PCB.footprints 0.position. .position. Okay, good. So now PCB.to file, right? PCB.fn. So then is this going to automatically update or no? Because I think I need to close it because it doesn't have any awareness that that actually happened. Okay, but it didn't move it anyways. But if we... Is it because of the lock file? Wait. Oh. Wait, but why did LED 32 move? Maybe it prepends them? How do I get the fucking name, dude? No, I don't want the library nickname. Pads, path, placed, position, private layers, properties. Okay, there we go. Properties. That's what we want. Oh yeah, and of course you have to return. Okay. So that seems good. So now we should be able to just list map get ref FPs. Do we have FPs? FPs is equal to PCB.footprints. Okay. What? They don't all have a reference? Oh my god. You've got to be joking. Okay. List map. Okay, so here we go. So now we have all the identifiers. There probably is a yeah, that's an easy way to do it. I'm fine with that. Okay, cool. So, yeah, so all the okay. So now we can come up with some stuff. What I want to know is position. Do we have any way to inspect documentation at all? No, that's sick. Sick, bro. I love that. X, Y, and angle. Okay, that's good. So if I do this and I double click on this and I get a position, X, Y, orientation 0. So it's defaulted to the right position. So we should just be able to, okay, so uh, so we want to def FP from ref. Yeah, let's make it, yeah, so then, okay, that seems good to me. So now if we do this, what? So if we do this FP from PCB, and then we want to look for DC1, right? Okay, then DC dot position is equal to position. And then if we do PCB dot to file, and then can we search for this? It's just all right. So does it update though? That's the question. So, is there a way to refresh? I think what I want to do. So here, let's say we close this, discard changes, and then we open it again. What happens? Okay, so it did do it though. So is there a way to? Is there a way to trigger KiCad PCB editor to refresh and reparse the KiCad PCB file? I'm editing it in code, but it doesn't automatically update. This is so dumb. I don't know. It's just naive, you know. I was like, oh, I can do this in like one day, but I do have a lot of work, man. In any case, I think it's so one thing that's interesting though. Uh, wait, where is that? Where is that thing? Tools, scripting console. So if we just do, what do we do? Nice. Okay, so let's try that. So if I now mutate, okay, so let's say DC dot position is equal to x equals 100. And then we write it to a file, and then we go over here, and then we do PCB. Okay, and then we go over here. Yeah, it didn't work. I wrote it to a file, right? Yeah. Okay, so I think though this is the path forward. This does make sense. We're basically going to we're not going to place everything, but we're going to basically figure out what the grid and the for loop needs to be to place all of these. Okay? Then we can just shift them to wherever they need to go. Because we can just move them once they're all relative to each other. We can just move them. That's fine, and then we'll manually place the DC connector, the MOSFET, and the other stuff. Um, and then we can be done. So I think now it's time to find a MOSFET. I don't think I need that. What if I just look up transistors? Bipolar MOSFETs. There we go. So what do I want? I want something that's going to um um does the RPi 5 GPIO outputs use 5-volt logic or 3.3-volt logic? Because hopefully they both use 3.3-volt. Okay, so if in my design I'm trying to make my design usable with a Pi or a Pico, and they're both 3v3, so just pick a FET. So I don't actually know that much about MOSFETs. Drain to source, I mean, see, like, right already there, drain to source voltage, 1 N channel, that's probably right. 1 N channel. $300 million is not enough. Current, we're gonna need to source like, well, let's see. Realistically, we're not gonna actually have to source that much current, because let's just say we have like, for safety, let's say that we're using 40 milliamps per wait, hold on. We need to figure this out because I think that yeah, see, I see a big part of this project is just understanding. Whoa. Oh, I think I have these. I think I literally have that part. IRF Z44. I mean, that's a is that real? 94 watts, dude? You need a heatsink for that. All right. So wait, hold on. So I think that at most, if we just say that there's like 50 milliamps per 50 times 36, 1.8 amps, that's kind of a lot. I don't know what kind of safety margin you're supposed to put on. You can pick a logic level N MOSFET that turns on hard at 3.3 volts and you'll be fine. Okay, so we want a 1 amp logic level. Okay, let's just look up the specs on the one that it recommends and then see what the deal is. 7 cents. But this says that it can only handle. It doesn't even tell you a drain current. Wait, the minimum? This one's 3 cents, and they have more of them. I guess the footprint is different. This seems good to me. This one seems like it. 30 volts, 5.8 amps. What does this mean? Help me. Yeah, I need help parsing this. Okay, so that's the VDS max. This is the this is the continuous drain current rating at a certain case ambient temperature. It's not really telling you can always push 5.8 amp. That assumes that the package has started a big copper pad for cooling. In a tiny SOT 23, a practical current is usually much lower before it overheats. This is the resistance from drain to source. If the MOSFET is dropping voltage times current. Wait, so then what is the... Oh, so if... Okay, so wait. Do we have a RDS at 5 volts, though? Do they give you a plot? Do they give you a plot of RDS? Okay, here we go. RDS, milliohms. So at... Wait, ground... What is this? What is the G? Gate? So the gate source should be... The gate source will be even less than that. Oh, and then here we go. Here's the transfer characteristics. Bro, actually, it's kind of cool that I can understand these plots. So this is in amps. So the drain current, I don't know why they can say that they can... The drain current is... yeah, okay, wait. I don't understand that plot then. Okay. Okay, so if we take RDS on 50 milliohms, even that's high, and you run 1 amp through it, then we'll have 50 milliwatts. Okay. So this part seems pretty good. I feel like I can use this part. Cheap everywhere. Okay, um because drain source voltage, because okay, so just to clarify, in my setup, VDS will be 5 volts. VGS will be 3.3 volts. I should um wait, power V equals IR for Ohm's law. Power equals VI. So if you replace V, P also equals I squared R. The loss is 50 milliwatts, which okay, now so we found an NFET. Good. Now let's figure out trace width stuff, because I have a few concerns. The first is I'm guessing I may need a thicker trace from the barrel jack to the FET, and maybe the FET to the LEDs. Because then I am almost positive I need a thicker trace from the jack to the USB A if I'm going to power a Raspberry or Pi with it. Okay, we're making progress actually. I'm ready to slam this thing into the ground, man. Okay. You're thinking about the right things here. Okay. Wait, how does an N? Oh, wait, how does an NFET work? I feel like I got it flipped around. Okay, well that's good to know that I can't use USB-A. What is that? I feel like it recommended me to use a USB-A though before. One amp through a 40 mil, 1 ounce outer trace that's 50 millimeters long, 24 millivolts drop, so 24 milliwatts of heat. Okay, so what is a pour? The thing is, the pi seems really convenient. Right, so what can I do to power my Pi? Or even use my Pi to power the board. I don't even know what that means. What is a power O-ring? Oh boy. USB power delivery is digital protocol that runs over the CC pins of the USB-C connector. With PD, the source, your board, and the sink exchange messages. The source advertises what voltage currents it can supply. Let me go get my Pi. Using the Raspberry Pi seems less attractive now. It seems really annoying. Let's just use the Pico. Why not? So the Pico, all right, it's time to figure out how to use those transistors to. So this might be complicated too because we need to go get one of those MCDC2s. MCDC2. Okay, we're settled. It's settled. We're gonna try to explore because I don't really want to do this. Or you know what? Actually, why don't we just okay. So if we have the Pi powered separately, so we have two power cables, which I'm not like we leave the USB A in because I do like the idea of having both options. So basically there's two options. Basically with the Pi, power it separately. And we have to think about the enclosure design because we're going to need to be able to maybe we could just mount the uh maybe we could just we drill a hole in the thing and stuff it with, and then we just mount the computer on the outside of the box. It's not like the best, but I don't really care. We just need it to work. Okay, yeah. So it would be like so we'd have a box and then we'd have a box around it as a sleeve, and then we're just going to have like 4 bolts or maybe 8 bolts that go into like a base. And then there will be a hole. So this is the PCB and the stack up or whatever. And then there's going to be the board is mounted, the Pico Pi mounted outside. Okay, so then power it separately. Pico use the USB A. So then um okay. All right. I like that plan. Okay. Holy sh! This is a way harder project than I thought it was gonna be. Not hard. There's just a lot to figure out. So, and like for example, um, the Pico will probably just have a MicroPython program that just right when you plug it in, it just starts doing the thing. But like maybe that's not what you want because yeah, maybe that's not what you want. You know what? For a first draft, it should be fine. Okay, so let's So what are we doing? Are we doing it in KiCad or are we doing it in Attapile? If we look at the, we can close this. If we look at Illuminator, wait, that's the Python. Um, let's use Attapile. Let's use Attapile. So we're gonna use Attapile because I figured out how to do the array thing. So let's just I'm gonna close this. We go over here. Then we're gonna do UV add. What is it called? What is it called? Chi utils. Okay, then in main.py we can do this. And then we can switch the them to here. Okay. Okay. All right, so we can now do the thingy. Okay, give me a sec. Okay, so in the case of the Pi, we need literally one signal that turns on the MOSFET. And we can pulse width that. We do need to figure out, so we found the NFET. let's add it. But we need to figure out because basically N versus P fet. Like I don't know what the schematic should be. So, but let's just add the part and let's get it. So we have, oops. I think it is this. So this is, wait. Yeah, this is the one. I don't even know what this is, but that's fine. That equals new. Okay. I wonder if they have named things. So we have the, okay, so we imported the fet. Now we need to figure out what are my options. Okay, I think I've decided that in order to support both pi and pico, I will require that the pi is powered with a different power cable. But the pico can be powered. The thing about that is like so wait, so what am I trying to figure out? I'm trying to figure out if I power the pico through VSys pin or whatever that thing is. Could I modify the code while it's plugged in? I don't need to switch the, well, actually if it's like, because the pico is not delivering any power. It's literally just turning on a FET. So okay. Now my question is, well, so okay, wait, so all right, so let's just go in order. So all right, let's find a USB thing now. So Solid plan. Here's a clean way to wire it so your board works with Pico or Pi without surprise. Must be powered on its own cable. Can be powered with the... Okay. Power domains. Actually, you know what I'm realizing though? No matter what we do, USB-A V-bus, the 5-volt that goes out of your board. Pico V-sys. The Pico's V-sys pin. Recommended power. Wait, why would I do that? Wait. Oh yeah, we're gonna need a decoupling capacitor for sure. Polyfuse. What is a USB power switch? But we do need to figure out how to share ground between the Pi and Jack, because no matter what, if you're gonna be doing this logic stuff, then you need to have the grounds tied. If you're powering through the USB connector, you're using V. Okay. Oh, that's cool. Oh, polyfuse, dude. The polyfuse are cool. Let's see. USB power switch. Okay, so then that means that the four signals. Wait. Okay, so I'm gonna need FET, ground, and snap pick. This is gonna be Pico only. This is gonna be Pi only. The thing is if I'm using Pico for MCDC2, I know there is two modes, one for focus and one for snap. If I'm on manual and manually adjust the settings, then I should only need one signal pin to trigger snap, right? I want to keep it as simple as possible. Like, is that a real checklist? No, I can't click on it. You only need to short the shutter. You need to short it to ground. So I'll just use a. Do I need a resistor in the path, or is a small transistor that literally connects the shutter line to my jack ground? And then actually, um, yeah, this whole thing is gonna be collect BCE. Wait, hold on. So collector goes to MC DC2 shutter. Okay, wait, so hold on. So this is the shutter pin. The base, the emitter is the MCDC2 ground. And then this is Pico through 10K ohms. Base to ground pull down. Gate to ground. Oh wait, no, hold on. Base to this is a BJT. I kind of wouldn't. I kind of want the no current draw. Yeah, keep grounds isolated with an optocoupler. Hold on. This avoids any direct electrical. But would it work? Does it work? Oh yeah, it works. Optocoupler seems kind of like the right idea. I kind of like that. Okay. Wait, an opto has 4 pins or 3 pins? Inside the little plastic bag, there are 2 parts of a big, tiny clear cap. Oh, dude, optocouplers are so sick. I feel like that's just fun, but also, um, so then, okay, all right, I'm so down to use an optocoupler. That seems fun because then I don't have to like. I mean, maybe it wouldn't be that hard to tie the grounds together, but this seems like a nice way to do it. So I gotta get one of these cables. I feel like I had one of these cables, but okay. So all right, so this is coming together. Actually, I mean, it doesn't seem like we're making any progress, but we actually are making progress. So any USB A will do, right? Since the Pico takes small amount of current. All right, we're almost ready to test G Photo. It's funny because my to-do list has just gotten much longer. Okay, so um, so we found our NPN optocoupler. So we need to find an opto bin. I just like saying optocoupler. All right, we need USB. Okay, let's just go with type A. Through hole USB. SMT seems more expensive, doesn't it? Most USB-A is through hole. Right. Maximum current at which the contact temperature rise stays under 30 C. 30 C is not even that hot. You know, there's safety built into all of this stuff, man. It seems too small. Let's just go, let's stick with the plan. Do we think it'd be hard to surface mount? Do I think it would be hard to surface mount this thing? It's got these three. It's hard to see. Oh, is that pointing up? Oh, it's pointing up. That's a vertical. We don't want that. We don't want that. Wait, was that the micro? Wait, that was a micro, right? Yeah, wait, what the hell are we talking about here? Molex. Molex. Okay, so it's got these holes here. That seems fine. All right, well, we'll see how it works out. I mean, what's it rated for? Is it current? What? That's just a drawing? Oh, here we go. Okay. And it doesn't actually say the current, but this is not a data sheet. This is like a fake data sheet. Oh, okay. Maximum per con. It's kind of amazing that it can't handle that much, honestly. All right, so I think we're gonna go with the surface mount because that sounds fun. It sounds fun. All right, so I think we found a USB cable or a port. The thing is, these are kind of expensive. Aren't they $1 a piece? I guess if I get 10 of them, then they'll be less. But and I'd probably get like 20 of them. But ooh, if I got 30, what does that say? Lightning sale. Wait, is that the same part number? 480 372 100. Oh, but look at that. 90. Yeah, I don't think so, buddy. That one seems pretty good. Who makes that? Shunpu. What about this one? What's wrong with this one? Why are these? I mean, first off, it's crazy that it's 8 cents. I think that these are like the. First off, is that male or. Oh, that's male. Wait, hold on. We need a female. We need a female. All right, so this is what we wanted actually. So wait, we need a. Yeah, this is the Shunpu one. Okay, wait, but this is the through hole. So let's find the first SMD one. Okay, so we're gonna do an SMD. Okay, so we had the wrong part in the first place. It's got a couple of locator pins. Yeah, fuck it. Let's do it. All right, so we found a USB. This is the one. They have 8,000 in stock. I thought they had more than that. Wait, what? They have 26,000 in stock. Ground. Ground. Why are there so many pins here? V bus. So we only need V bus and ground. Oh, it's those other two. Yeah, it's those other two that are used just as a mechanical thing, but they're tied to ground. Oh, that's cool. Okay, so now it's time to test G photo. All right, so I'm gonna go get my camera, and we're gonna just test G photo. We're gonna see how this works out, because I really do wanna. I don't know why. It's kind of stupid, but I feel like it would just. I don't know whether or not it'll be more nice to do it. I feel like it's probably gonna be the easier route is just using the Pico with the MC DC2, though the caveat there is I don't know how complicated it's going to be to break out this MC DC2. It looked like there was some cable that already had a header, in which case we could just put a headphone jack on it and be done with it. I mean, that would be ideal. We would probably need to go through testing that. Okay, all right. Let's just keep going through the to-do list. So we're getting a camera, and we're going to test this thing out. Okay, so I think we have a problem because I think we have a problem because the USB cable. Well, this thing has a GPS connector. Man, these things got some whack ass stuff, dude. So, where is the MCDC2 connector? Okay, I need to, I need to, I need to figure something out. Is that an eighth inch? That doesn't look like a normal headphone jack. That looks like some teensy headphone jack that's not even right. Oh my gosh. Why is camera stuff? Bro, it's just like these people are so the camera connectors are like it's probably just a historical fact that like but they use these 2.5 millimeter jacks. You gotta be joking, dude. That's so dumb. Okay, well, I'll buy this. Okay, so I need to order this. Wait, what did they say? Micro B cables fit? Bro, no it doesn't. Wait, what is the MC-DC2 port then? It's something different? Is it labeled GPS? I see a... Okay, I don't know why I brought this HDMI cable with me. I mean, you got to admit, the cameras are quite incredible. Wait. I feel like it's the USB cable. Is it not a U? Wait, why did I go to Amazon? Wait, is it the GPS? Okay, so let's just order one of the... I'm trying to think if these coiled... I don't really want the coiled one. That seems stupid. I guess I could just resolder it myself if I wanted. Oh, yeah. Okay, so let's just order the other one then. Okay. Purchasing, bro. This is why people like, what is it called? It's not called acquisitions. There are people that specialize in sourcing and just finding the right parts. All right. So we got one thing that'll come tomorrow. And then now we need the UCE6. The UCE6 is I can use G photo with the UCE6, right? I wonder if there's a place around me that just has it, because I kind of do want to just go get it. Um, okay, so the plan will be to get a TRS cable if I don't know. I definitely have a TRS cable, and I'll just cut it, and then I'll just resolder it, and then I'll put a headphone jack onto my board because I have a bunch of those, and then I'll just hook that up to the optocoupler. All right, I think we have a plan now for. All right, so we have a plan for MCDC2, and we have a plan for okay, but if we go to all right, we're almost at the part where I feel like the length of the to-do list is going to stop growing, and they're going to be things checked off. We still need to figure out the all right, so here's what we've done today basically in the past 2 hours. Find an NFET, and we did, but now I need to figure out okay, we found an NFET, and then we found the USB port. And we added that to the Adapile project. Now we want to test Gphoto 2, so that led to, we have to get the cable. Then figure out MCDC2. This is going to be the opto coupler plus a headphone jack plus a spliced 3.5 millimeter TRS. Okay? Then signal connections, I don't know, JST something something something, I don't know. I'm not going to actually use what's it called? UCE6, right? Fuck it, I'm just going to buy it on Amazon. We'll test it tomorrow. Okay. Okay, good. So we also got get cable UCE6. All right, so we have two cables coming. Now we need to figure out the signal connections. And all right, so let's do it. Okay. So now it's time to figure out signal connections between Pi Pico and the board. The Pi will need 2 wires to the board. One for turning the LED FET on, and another to connect the grounds. The Pico needs 2 as well. One for FET and another for turning the opto coupler on. What are some good options to easily connect to the board and provide these signals connections? What's happening? My computer is frozen. We need to wait. For some reason, it's just really slow. Vertical JST seems cool. My favorite. Oh wait, actually, yeah, I'll have the Pico share ground. JSTPH. Oh, wait, did I buy a JST crimper? I think I actually have a JST crimper. No, I never bought a JST crimper. Not keyed. Yeah, I kind of like the idea of honestly, I'm not afraid to get a little dirty with the crimping. Cuz the thing that's nice about JST is JST, I think first off they're keyed, which standard pin headers aren't. I do want them vertical. No, wait. I want them horizontal, I think. But they snap. Do they snap? Oh, nice. Okay, so I think I'm gonna have to get a board space is not tight, so I think I'm probably gonna use the XH. But let's now go over to bro. I feel like I'm getting so good at electronics, even though I don't want to be. I just want to be done with this. Wait, JST. Honestly, though, low key, I could just use headphone jacks for everything. Wait, low key, bro? Okay. But then on the wait, I kind of want to use the JST though. What's the history of the JST? Wait, wait, what? XH is not 0.1 inch pitch? Wait, what? We need a new connector. We need a new connector. We need new connectors. There's not enough connectors. I think I'm gonna get some socks and some food soon. We gotta finish this today, bro. I'm so I wanna. I'm not. Okay, wait. Can I look for latch? Okay, wait. Let's look at what. Is there a YouTube video? So if I look up JSTXH. What is this? This is a 2. This is a 4. It's 4 cents a piece. It's not bad. I do think it's funny that like electronics are just like so based on this 0.1 inch pitch that like it's so hard to get away from. That's called lock in, baby. So let me see if I can find a JST crimper. I wonder if my DuPont crimpers will work. Wait, let me look at what it's actually called. Oh yeah, so I have a crimping tool that works with this. That's fine. A headphone jack is pretty strong. I mean, I tried to pull those things out, and I mean, they definitely take some force. Signal connectors. Okay, let's look up wire to board and just see what comes up as the most popular. All right, so JST is the most common wire to board connector. And they're all through hole. Dude, what are we doing, man? Oh, that looks SMD. But look how expensive it is. 16 cents versus 3 cents. I feel like JST is outdated, man. They have a 3-pin one. I probably would get the exact one that I want. I probably want a 3-pin. This is XH. 4 cents. That seems good to me. I don't want it through hole though. Does JST even manufacture the? Oh, they do. What is this? 16 cents? Honestly, maybe I'll just do that. I wonder if they have a. If we just go to 1x3p, and then wait, we already had that 1x3p. Do they have a mounting type? Oh, here we go. Surface mount, vertical. Okay. There we go. Molex makes them. Wait, this isn't even a JST. What is this thing? I don't even know what that is. That's a Molex connector. This is a JST, but this is not a... This is a GH. We want an XH. Do they have XH pitch? I probably have to do this. Don't even have a picture for it. The thing is, I feel like a lot of these are mislabeled under... yeah. Yeah, I've never seen this thing before. But I guess people like them. But it's definitely not JST. I mean, we could do this. But this is a JST PH. I don't know if we want to do the PH. So then we're going to have two headphone jacks. One that goes to the camera, and then the other one that goes to the MCU. Good. All right, so we're going to use a headphone jack. Bro, TRS is low-key like the freaking best. Like low-key, TRS is way better than all of these guys. Who doesn't have a headphone jack? But then it's like, oh, bro, you want to go crimping? No, I don't want to go crimping. Go crimp yourself. Go crimp yourself, sucker. All right. I don't know why this thing is loading forever. Wait, but the Opta, so okay. I always forget. So sleeve is ground, they said. All right, so we can close all of this stuff, right? We found the USB connector. We read the data sheets. We found the FET. We ignored power delivery because we're using USB. We found that it was a 1.5 amp thing. Okay. All right, cool. So the sleeve. Okay, so tip, ring, sleeve. This is good. The tip is opto. The ring is the FET, and the sleeve is ground. Add 100 ohms on the FET. I'm not going to do the pull down. I don't care about the pull down. All right. So now we have the signal connections done, and we can start to add it to our so we are going to need to do let's see. I don't know if I have it in. I definitely don't have it in here. I kind of don't like that the Adapod. I mean, I get why, because you kind of want it all in one place if you're gonna host it on GitHub. But also, it's like then I have all these parts just lying around with these. I don't know. So you know what? KiCad sim. Oh wait, actually, um, import sex. Um, UV add KiCad skip. We can just undo this if we don't like it. Um, schematic symbol. Will that work? This might fail, right? Let's try the other one. That psychogenic guy got to freaking fix his stuff, man. That's the problem. Is like these packages, they all rot. They rot. They freaking rot. Import symbol lib. That's what we want. It would not be that hard to do this. Okay. Entry name. Bro, I'm so sick of that. Bro, what? Oh, is deaf. Oh, wait. Wait, we got him here. I need like my own default Python standard library that like makes Python actually a real language. So this doesn't tell me though. I'm looking for um it actually might be PJ. Yeah, it is. Yep, that's it. Okay, so now wait, so S dot now we need to know S dot what are we trying to find? We're trying to find the like properties. Yeah, we found it. That was kind of an annoying way to do that. Okay. Okay. We're good. We have this thing. Wait, did it work? Where the hell is it? Oh, here's the PJJ. Oh, do I really need to freaking pragma this thing? Experimental feature. For loops. We haven't really figured out for loops yet. For loops a big deal. I'm not hating, but like for real, that's annoying. All right. So we got the headphone. We got the two headphone jacks. So I think it's time to figure out how we're gonna put this stuff together. Here, wait. Actually, you know what? We're gonna do this differently. This is gonna be the signal, and this is gonna be the MC-DC2. And actually, what we're gonna do is TRS sig TRS MC-DC2. And this is basically like for the opto coupler, pico shutter trigger. And this is the this is going to be, let's just write this down here. So tip to the opto coupler, ring to the FET, and the sleeve to ground. Okay. Yeah, the interesting thing about writing this big piece of code is that it's hard to know that if you got everything, you know, it's easier to know in the schematic that you got everything because you can visually inspect it. That's kind of a downside of this, because the thing about code for CAD, I guess it's easier to see that everything's right because you don't really, I don't know. Okay, so why don't we, wait, max current is less than or equal to 5 amps? No, the max current should be equal to 5 amps. Whatever, I don't care. So, all right, so let's figure this out. So the FET, so wait, if we look at the FET, UW, yeah, I really wish you could control click this, go to definition. Okay, so I don't really know how my, what is it called again? Is it called source? Dude, how do I just never have that happen? It's so stupid. We're getting there. Oh, okay. So we want. Okay, that makes sense to me. I remember I needed some beefy ass flyback diodes on the solenoid. I forget on the solenoid for the Nerf shooter. I forget really what was going on there. Oh, and you know what we should do actually? I need to have an inventory because I don't know what parts. I don't know what SM. I don't know what surface mount parts I have. So I don't know if I have 100 ohm. I don't know if I have 100 kilo ohms. So we're gonna need to go through and figure out if I um. Whoa, 1,001 millifarad. That's a big capacitor. That's probably not a surface mount capacitor. That's probably a through hole capacitor. Decoupling is bro, all these capacitors, this is all propaganda by big cap. Okay, I'm gonna make some food and then we're gonna actually finally wire the rest of this. And so this is wrong. So this is wait, jack one. No, this is right. Except for this. This is not right. This needs to go to FET's drain. So this needs to go to fet.d. And then okay, then we're gonna okay. Let me make some food. Okay. Okay. What's a standard way to do this? Do you think you're better off alone? Do you think you're better off alone? That's actually right. Does the USB not have anything? Yeah, it does. Wait, did it actually error? I swear, it just constantly errors, but it says nothing. It's like, this is the stupidest. Oh, yeah. All right. Headphone jack, USB, headphone jack, DC, LEDs. All right, we are getting closer. I'm gonna get some ice and some LaCroix, brother. Brother, I am getting some ice and LaCroix. We're gonna get this shit started. Actually, take a walk around the block, and then I'll get started. Yeah, I got my LaCroix. I'm fucking pumped up. It's a beautiful day in California. You know what? I really wish I was networking right now. Connecting with stakeholders. Meeting people eye to eye. I really wish I was boots on the ground. Talking to customers and making them feel welcome and whole. Man, I really wish I was networking right now. Hi, hey, hi, my name's Anand. Nice to meet you. Hi, yeah, David, was it? Hi, nice to meet you. Oh, and what do you do? I really wish I was networking right now. Oh, God, I wish I was networking right now. All right, so where were we? So we have, okay, so wait, hold on. I actually want to do it this way. I feel like this makes more sense. Jack 1 and 2. Is there a way to alias that actually? Like, is there a way to say ground? Can I? Oh, I think I could just do this. I think I can just do signal, ground, and then we can just do. Or actually, what we want to do is we want to do the other way around. We want to do this goes to power 5 volts at high voltage, a low voltage, and then we should be able. What's wrong with this? No attribute power. See, it's just crashing every fucking second. This thing is so bad, man. Oh, there we go. And now it stop, dude. Can we just ignore this? Turn off. Stupid. Okay. So now we can do V to jack 1. And let's just call this ground. I'm not going to capitalize it. Let's call this V. Okay. Dude, I just said settings. Ugh, whatever. You can't even turn it off. It just bothers you all the time. All right, I don't give a fuck. All right, so then this is good. So okay, so then what is a signal? I feel like that's not right. Oh, creating name nets. Yeah, cool. Okay. Um so one thing that we need to do, because this TRS, it's the PJ, uh I could manually edit this, right? Wait, this might not even be the right product. Wait. No, I think it is. It's the same freaking data sheet. This isn't even a data sheet, man. This is the only thing that we get. Okay, so what we're gonna do is we're gonna comment this out. Signal S goes to pin 1. Wait, actually, how should I? Let's just comment this one out. Okay, so maybe we ignore pin 2 and 5. Okay. Yeah, TRS sig dot tip is the optocoupler. We don't have that one yet. This goes to opto. So I don't know what type of optocoupler we're supposed to use, but why isn't this working? It has no attribute S. Okay, when we look at the transistor, for instance, signal D is connected to pin 3. So I don't understand why this doesn't work. Let's just do this. One, two, three, 4, 5. What about now? What? That's weird. The auto router is then gonna place those in as a net together? Then the FETA gate goes to this. That's true. All right, so let's just ignore 2 and 5. Oh wait, you know what I forgot? I forgot all the resistors. Okay, so I guess my to-do list grows because I need to index my parts, especially SMD. I really don't want to do that. Let's actually just look up optocoupler. Why does it only have 3 contacts? Or no, it has 6 contacts. Okay, wait, hold on. Let's just look up this thing. I trust it. It knows what's up. 80 volts, 5 kilovolts, 50 milliamp, 200 millivolt. What does that even mean? I don't even know how to parse that. Dip is the same, right? No, dip is through hole, right? They're pretty expensive, actually. Oh, wait, no, they're not. 8 cents, that's fine. Oh, dude, this is so cool. I love optocouplers. All right, so this is fine, right? We can use this. 50 milliamps. How much current can a GPIO? Bro, this is getting too long. We need to actually start a new. I think what I'm gonna do is can I share? Oh, what? So the voltage is 3.3 volts is equal to I times 1,000 ohms. Is this the one? Yeah. Oh, wait, hold on. We're going to do a new one now. Okay. Well, what I really want to do is I want to try to get this to work. I think that I mean I bought the remote, so tomorrow we'll be able to test it out, but I really want to I think it'll be cool to try with the opto. Okay, so I probably have a 1 kilo ohm resistor. Apito coupler. Apito coupler. Apito coupler. Apito coupler. Okay, so wait, we're looking for a control F. Find page 1K. Yeah, Gale. Yeah, Gale. It's crazy that they have 12 million of these. I mean, bro, I want to see a an 0805 resistor factory. So I bought these. So what we just need to do is we just need to add these to the project. Apito coupler. It's probably duplicating all the 3D models, which is kind of silly, but it's because these all have step files, but I don't care. Okay, so we have the 1K resistor. Do we have the 100 ohm resistor? Okay. So what we need is um the this the sleeve. Oh, the sleeve goes directly to ground. That's okay. The but the ring goes through a 100 ohm resistor. So R100.1. I'm going to do is the FET. Okay, then we have the TRS sig dot T, right? Goes to the RK1, and then this, not to that, but to the opto, which we haven't added yet. We haven't added the opto yet. So Autopilot could be cool, but it just like sucks. And that's how I feel about so many of these code CADs. Is like I see the vision and I love it, but then using it, it just stinks. All right, so what are we doing? We are finding that. Okay, so wait, we have to look at the opto. So I'm pretty sure that the opto. Where is my opto coupler? Where is my opto coupler? Okay, so oh yeah, so pin 1 and pin 2. So then we're gonna connect the the Pico's tip is gonna go through a 1K, so that's true. And then the R1K.2 is going to go to the opto.1. And then the opto.2 just goes to ground, I think, right? I just wish this LSP would shut up. Um, okay, so now what we need to do is we need to figure out what's happening with the headphone jack. So the headphone jack, we kind of have. What we're gonna do is we're gonna connect the sleeve because the sleeve is already called ground. Actually, see, that's kind of goofy because we kind of didn't want to do this. Oh, no, no, no. All right, yeah, that's fine. So what we're going to do is TRS MCDC. But we don't need to actually connect that to ground. This just needs to go to opto.4. And then this is going to go to the tip. It's going to opto.3. 4 is the collector. So the sleeve is going to go to ground. Or the sleeve is going to go to 3. Wait. We need to figure this out. Okay, fine. We'll add a. Let's see. Did I get a 100K resistor? I probably did. Alps Alpine. I love that name, dude. It's such a goofy name. Fujian. Okay, wait, hold on. That was a 220. This is a. Okay, so I did buy a 100 kilo ohm. It's this FRC. Here, I have the. Okay, FRC. I don't know who makes that, but we have it. Okay, so we just need to do add part. C29072. Wait, hold on. Let's do this. C2907217. Fojan. Fojan. Okay, so now I just need to import this, and then we're gonna do R100K is equal to new Fojan, and then here what we're gonna do is we're gonna tie the gate R100K dot 1 to fet.g, and then so this is gonna be a gate pull down. T goes to 4. Okay. Dude, that's so stupid, man. This stupid MCDC2 thing. I think we're gonna have a pain in the butt time trying to figure this thing out. We can take apart the handle and maybe figure it out, but basically in this cable, so the tip, I would assume we want to go to the collector. Is that right? Tip. The tip is the shutter. Tip MCDC2. Tip is the shutter. Sleeve is the ground. And then if we have a standard transistor, and then we have the collector and the emitter. This is an opto. Then we have a. Then we want the tip to go to C. So tip to 4 and sleeve to 3. Okay, so what did I say? I said that tip to 4, S to 3. Okay, good. So are we done? Did we just finish? I feel like there's no way. Wait, we didn't do the. Did we finish all the signal? Wait, let's write this out. So, uh, okay. It's kind of weird that like ChatGPT can't call ChatGPT. So this is from 8/28/25. Okay, so These cameras are actually really advanced. Uh, What is it called? UCE. Oh God. Okay. Um. Oh, actually, you know what? I'm just gonna get an adapter. Bro, I'm dumb. I'm just gonna get an adapter. They definitely sell adapters. Okay, so I got some adapters. So that's good. Okay, back to documenting. The second TRS connector is used to connect the MCDC2 connector to the camera. Uh, oops. Okay, great. Um, the the path is uh 5 volts to R to LED to FET drain to FET source to ground. I believe that's right. Voltage to resistor, resistor to LED anode, cathode to drain, Source to ground. Do we have the let's try to build it. Okay. Oh yeah, mounting holes. We need mounting holes. How do I do mounting holes? I think I can just do this here. Oh, but you know what? I need to I mean, it's crazy because it's only like 70 lines of code, but this thing is sick. I actually really like it. Okay, so let's push the docs. Wait, okay. Oh yeah, we need the decoupling. Did I actually connect the tip? So that this thing tip just goes directly to the opto, but they're saying put an ESD. Okay, so oh yeah, decoupling. So we need to add decoupling. Wait, so what is the purpose of this? This looks like a way bigger project because of all this AI shit. Yeah, shit. Okay, so wait, hold on. So the jack one. What is the PTC? What is PTC? Oh, the polyfuse. C 5 volts is OU1. I don't even know what that means. Wait, how did they do it? What is an ESD cam? I don't know. I just don't want to damage the camera. That's my main thing. They make it sound like I'm going to damage the camera. And I would really, really hate to do that. So, mm. Actually, that would be kind of cool. Well, it should be like $50. Okay, so we're not doing this. I think I have 100 microfarad. Schottky! 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 Mm, 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 mm. All right, we are nearing the end of the schematic, man. We're ending the near. We're nearing the end. What? What the hell? I don't understand what they're saying about the 100 microfarad capacitor. Place it near the LED array. Okay, that's just a placement thing. So we have a 100, 10 nanofarads. Wait, 100 microfarads? MC, MLCC. Let's see, how high do these things go? That's a beefy boy. That's a beefy, beefy boy. But yeah, hell yeah, we'll do that. So we'll get 100 of these. Spend $5 on. Let me go to the GitHub issue, my issues. I mean, this is annoying. You have to manually copy this thing in. I don't know why they make me do this. Anyways. Okay, so C100 UF. Okay. So here we're just going to add Konsamida domadebadom bum 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 bum. I think I do have a point. Point one is 100 nanofarads. So, but where's the 100 nanofarads? Here we go. C496. C49678. All right. I genuinely I feel pretty good. Okay, we did the wait, what? I wish I could click on this definition. I don't even know what this is, but I'm just gonna leave this in again. Okay, so now we have okay, so it's time to start writing Python. So we're gonna try to put this thing in a grid. I'm gonna walk around the block though. I get antsy at 3 p.m., bro. Okay. Okay, all right. That's enough of this crap. So what we're gonna do is ah, the hell is that? Okay. So let's remember. So we're going to close the PCB. Okay, we're going to go to main.py. UV run Python. Then we're going to do, this thing. Actually, wait, I don't want to. I just want to load these because skip isn't helpful. So let's footprint from ref. That's actually what we want. We want footprint from ref. Okay, so what we want to do is figure out the spacing between. Oh, so I guess we need to open up the launch KiCad. These can literally be this close. I think that's fine. Right? Isn't that fine? That works for me, man. Did we do 0603 here? I think we did. That's a tiny freaking... That's a tiny, tiny LED, man. Ooh, add a pile address. That's cool. All right. So basically what I want to know is the position of this thing. Okay. All right, so the LED is at 23.025 X and Y 15.875. And it's orientation, okay, and orientation 180. And then, oh wait. Wait, what? And R is at X 19.415 and Y is at the same. The orientation is at 0. Okay, so now what we want to do okay, so the spacing is equal to 3.61. Okay, so what we're going to do, does this have, what is this? R1, R38, C2. Let's get all this stuff out of the way. So wait, hold on. But what we need to know is the way that it compiles it. Like, for instance, like I want to delete everything. If I delete everything and then I do... It doesn't have it because it's a floating thing. So if I save this and I close this and then I launch KiCad, presumably it just launches it empty. Good. So now what we want to do is we want to make sure, though, because we're going to be doing everything based off of identifiers. So if we build this, this is going to build the PCB. So it's compiling the .KiCad PCB. And now we can open KiCad. Oops. What just happened? Okay, and now it's all like lined up for us. The weird thing though, see, that's so annoying. Okay, so it's just shifted by 3. Okay, wait. For now, while we're waiting, let's just keep going. Come on, I gotta finish this thing, dude. I'm so sick of this. All right, so we got UV running. So what we want to do is, okay. So we're gonna take. Okay, so X R L R lead X delta is equal to 3.61, I think millimeters, right? Which is, I think that's fine. Okay, so what we're gonna do is start our. So then we want to grab. Oh wait. RFP. Let's run this thing, dude. Wait, that's not even right. Wait. I think we have to do X equals Y equals angle equals 0. Then we want to do, how do we write the board? PCB.2 file. Layouts, default. Oh, yeah. What? Wait. Oh. Okay, so it saw an update. Oh, wait. Close this. Open anyways. Okay, that's cool. So it did it, but it didn't do it. Right. It did it. So what we want is um this is the millimeter distance between the resistor and its LED. So we didn't even use this. It seems like it worked, right? Um Bro, I'm a baller. I'm a freaking baller. I'm a freaking baller, bro. What's the position here? Wait, I want to not select the pad, but the whole thing. So wait, that's not right because C1 R1. Right, because we want a 6x6 grid. So wait, actually, hold on. I think we want to do over 5, don't we? Error is not defined. Do I have to say throw? How do I throw an error in Oh, it's raise. I'm gonna leave that in there. That's funny, man. Okay. Um and then angle actually needs to be 180. Does this make the invalid value for bool? I think it's supposed to be capital, isn't it? Wait, why are the What is that? That's fab, right? Yeah. I feel like that's maybe a little too close. Hold on, let's try this one. All right. That's actually so cool. Oh wait, but the wait. Wait, why does it have so many? Why does it have multiple? Where is this even tied to? There's two of these. I don't get that. Okay, wait. Let's delete it all. Rebuild. So now we're gonna build the PCB. Please don't open Kai. Actually, if it opens Kai, we'll just close KiCad. Wait, what happened here? Wait. So yeah, that doesn't make any sense to me. What is this? Oh, this is the decoupling. But I don't understand where these other... Okay, what if I... Okay, wait, hold on. I have an idea. We're going to delete everything. We're going to save. We're going to close. We're going to build. And we're going to... Wait, is my stream still on? Okay. Okay, so we're going to build it again. And we're just going to see if there's duplicated... Because I feel like it's probably a bug with this, not with... Let's see. Yeah, so somehow... I don't understand how this code is... I just don't understand how this is creating a freaking additional... I mean, I'm trying the exact same thing that I already did, so I don't know what the deal is. One's a little smaller. I mean, why don't I just delete the other ones? I could just delete the other ones. I don't really care about that. Oh, wait. Oh, but this one I can't delete. Oh. So somehow this one is actually for real. Wait, what? No, wait. This one I can... I need to delete that. Here we go. I don't know what the hell is going on. Okay, but I guess we're going to need to... Okay, so the reference designator position. So now we need to add the silk screen placements. So the delta y is minus 1.905 millimeters. So what we need to do here is we have um, oops.
I said, what is up? I said, what's up? I said, what's up to the homie?
Okay, so wait, hold on. So okay, so we have LED FP, and we want to find the LED FP dot graphic items, right? And then we want to find the unique. So there's a bunch of lines. So wait, if I do map L, oh wait, I need to run all this. Wait, do I have map L? Bruh. Wait, do I have it in here? Wait, is there a tally function? 16.2. Wait, there's two texts? Wait, why are there two texts? Wait, but oh, you know what it actually is? This is on the fab one, but see, we don't care about the fab one, and honestly, I don't even know why it gives me like a UUID on the fab. I don't know what the heck that's about, but we just need to find. So there's only one on the text. So wait, hold on. So wait, we want to filter. Okay, filter. How do I use it, bro? Wait, can I do UV run IPython? The default Python is just so bad. There's no way to read documentation within the REPL. God. Okay, so fine. You know what's hilarious is that like this real Python thing is SEO'd it so that the actual Python documentation is nowhere to be found. Like, where is the real Python docs? Oh my god, Python documentation. It's just psycho, dude. Beginner's guide. Quick search, filter. Wait, what? Filter? Okay, so filter, it's just a, okay. So, an x dot layer is equal to f dot silk. Bro, what? Wait, what? Oh, because I just, oh my god. Okay. Shit. Ugh. Okay, so let's just rerun this stuff. Okay, so what do I want to do? I want to filter. So wait, so GIs is equal to LEDFP dot graphic items. Okay. Now I want to do this. Oh my god, dude, what the hell? And I don't even think they have a pipe object. So it's just like total. It's like, does Python have a pipe? Okay. I don't care about doing that. Okay. So we did it though. So there's only one FP text. So this is the predicate. So um uh um okay, we can comment this out. We can move this up. I think I need to do it twice more. And then I need to comment this out. I need to put this in. Okay, so all right, so we're good. So the idea is that what we want to do, but okay, wait. So we have, so this is going to be the, so this has a position, right? Okay, sick. Oh, but where's its center? Offset Y 1. Why is that positive? Oh, okay. I understand. It's because of the freaking but that's okay. So that's fine. It literally doesn't even matter. But what's this stuff under here? That's what I want to know. Oh, just this like pad of ground, pad of R4. Oh, geez. Oh, geez, Louise. Okay, so what we're gonna have to do. Okay, wait. So I deleted. Okay, so let's find. So we're gonna do the same thing again. We're gonna do. Um. We're gonna do. So do we have R4? Do we have R? We have RFP, right? What? RFP dot graphic items. R. Okay, so now. Wait, what? Is one of them like on a different layer? Because that's just like not true right now. So somehow it got. Oh, yeah, and you have to add it to every function that you want. That's silly. That's fun. Okay, wait, so but so then that means that there's another. There's only one. Wait, no, there's not. Wait, but this is no, this is the fab one. So what I want to actually search for, use a library tools. Um, we're trying to find this literal thing. Its text is literally R4. So what if I look for text? Why is my computer frozen? Oh no, is this recurring? No, I don't know. Something's weird is going on. What's going on? All right, it's clearly not recovering. Oh wait, it did. Wow, I'm so surprised. Okay, text equals what? Why isn't it moving? I mean, I just okay. Wait, what? I'm like fumbling. I'm like bumbling and fumbling. What? What I believe to be happening is that it's like okay. Wait, if I read this again, I close this thing. I save it. Okay. Okay. We're gonna reread the board. PC PCB equals. Oh my god. Ah, bro, I'm getting so sick of this thing. All right, we're rereading it. Okay, now, um, R F FP is equal to FP from ref R4. Okay. Wait, where's the other ones? It says there's 4, but I don't see any. If we actually just manually look at this thing. Wait. How did this happen? I think we need to delete this. I don't know how that happened because that's not right. We don't want that in there. It's saying that literally doesn't exist. Hold on. I'm so confused. Like, why is that in there? I just don't know where it's. I just don't know. So okay, wait. If I reran this, let's run it again. Did it make that profile again? No. Okay. That's so weird, man. Like, where is that? I need it. I have to delete those. What if I can I just search for? Bro, what? How do I wild? Oh wait. Wait, can we find this? Like, according to this, they don't even exist. If I rebuild, for example, bro, I am getting so triggered. That's not even accurate. Wait, okay, but you know what we could do? Wait, also, that's all of them, right? Oh my god, I just want to be done with this, dude. This is not fun, man. So what options do we even have here? We can just manually delete them. But that seems really annoying. So what does this code do? Hi.
My brother, what are we doing here? Take me to this foul place, you Latin.
So here's what I'm thinking. Realistically, can we just get away with not dealing with this in like these are the big ones, or no, these are the small ones, these are the big ones. But like, oh, but even this. Okay, wait. So it wrote some. Okay, wait. What where are we at here? Wait, Adipile expects yes, no. Are you sure? Oh, yes, it does. Let's just freaking get this done. I mean, I don't know if trying to vibe this is even the right thing here. Did I already paste that function in? Okay. Okay, and then we also need to run. Oh. Okay, let's freaking try to. So what we're gonna do is this is open. We're gonna do delete, save, close, build. Okay, build successful. Now we want to do uv run main.py. Okay. Please, 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 please. Come on, baby. Okay, so we only have the big ones, which is fine, I think. I'm like fine with the big ones, right? So okay, so we have LED one. It's gonna go right here, and then R4 is gonna go. How do I change the size of it? Thickness. No. Why does it say that the size is? Because I think that that's not even the right. This is the F fab, but in the. I don't know where this shit comes from. I think who made that? I think maybe because are they all? So it's undo. Are they all? Is it R40? Actually, do we want to just change? We're getting close. Okay, wait. Also, I want to. We're vibing this, man. We're vibing this. I don't, because at this point, it's about getting it done. I just don't know if this is gonna be right. Does this read the? So it like didn't even. I think I would need to do this after maybe. Wait. Is the text smaller though? No. I just need the whole thing. At this point, I'm ready to vibe it out because this is stupid. Because nothing got changed, right? Like this thing. Is it because they live in the mod? Like if you go to the that doesn't even make sense. Wait, did I ever check that that actually is right? With the position of this thing. Oh yeah, nice. Wait, okay, wait. So let's do this. We're just gonna rename this. Old. Okay, let's just trust in the AI to do this thing. Because at this point, I don't actually give a shit. My guess is that it's still messed up. Bro, I'm straight. Deep research. Take your time. Take your time. Figure it out. This is so stupid, man. So what we're gonna do this thing again. Delete, save, close, build, copy. I still don't think anything is gonna happen. To be honest, I really don't think anything is gonna happen. UV run main. Okay, nice. That actually looked kind of good. Please, 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 please. Oh, yeah. But it didn't remove the duplicates. It got rid of the duplicates. We're close, man. I don't think this is going to actually work because I think that these are the... Like, I think that, like... What is the right way to do this? I have no idea. This is like the most bottom of the barrel. You don't even want to think. You just want to move on. My God. Okay, I am determined to not have to think about this and just let it vibe. Oh shit, that's not what I wanted to do. Yeah, this is not this is not gonna work. Oh wait, no. I'm gonna build it and it fails, right? Yeah, I'm actually so annoyed right now. And we're gonna build it again. We're gonna build it again, right? Okay, and then we're gonna. Which one? What does old do? I think old. Now, if I try to rebuild it, does it error? But if I open it, but I want it to build. Like I want to use the right S expression thing. The thing is, this isn't even right, right? Oh wait, actually wait, undo. Bro, how do you select something? The issue for me right now is that I don't like. Wait, did we mess this up? Yeah. Yeah, the biggest issue to me, like I love this, but if I save and then I try to reparse it, it fails, right? Which to me that's a no go because I really need it to be right. Okay, I guess that's fine. I guess we're good. Okay, wait, actually, hold on. So now we want to jump to edge cuts, rectangle, rectangle, draw this, edit it, corner and size 0, 0. We're going to make this 110. We're going to make this 130. That's how big it is. Okay. So wait, actually, wait, hold on. Can I rule other items? We don't want other items. Yes, KiCad. I freaking love KiCad. Shit sucks, dude. This shit sucks. Okay, there we go. So if we were to do this, that's awfully close to the edge. But if we move them up, that actually might work out really well. So is there a way to group lock group items? Okay, sick. So now if I move what? What is this extra fucking thing here? Anyway, so now if I edit this, no. Can I edit the group to have like but I want to move it to a specific location with text, not with this. How do I move it to a how do I name the group? Objects. Wait, but actually wait, hold on. Let's try this. If I take this guy and I move it to yeah, let's say 330. Oh, great. Yeah, that's so cool. Now it breaks the whole group. Isn't that nice? That's so stupid, man. Why? So is it grouped now or not? No, of course it's not grouped anymore. Oh my god, bro. Is it still grouped? No, yes, of course. Why would it be grouped? This is just way harder than I wanted it to be. All right, wait. Let's just try to get something right. So, why can't I move this? What? Am I in the group? Is that what's happening? Okay, I was in the group. Apparently, if you're in the group... Wait, but does that mean that I can... Okay, I don't know. So let's just put the power cable in the middle, I think. Let's put the decoupling... Like right here. This is also decoupling. Okay, this is the optocoupler. This is the FET, right? This is the FET, so this should go like... Is one of these no connect? Oh. These are no connects. This is ground, this is VCC. What is this going to? What is this? This is going to the... Oh yeah, that's right. This one... is just going like right here. What is this? Oh yeah, the mounting holes. Shit. What is this? Ground. What is this? Wait. This doesn't look right. The whole symbol for this footprint. The gate is here? I don't really buy that. AO 3400A. AO River. Oh, I guess it is. So that is the drain. And then this goes to ground. Where does this go to? That actually looks pretty sick to me. And I guess it parses. Oh, what? Wait, excuse me? Oh, I think it's just I think it's not. No, I think it's fine. I think it's just another one of those, like, things where it's, like, weird. All right, so let's save this and try to route it. I think now that the routing is correct, it'll actually be able to figure it out. Maybe not. Oh, this stuff is fine. I don't care what the V is or the whatever. We should at least flip that around. But what are the unconnected nets? Does it show me what's missing? So if I cancel. Okay, so what's missing? Nets unrouted 131. Okay, so wait. Wait, why don't I just do this? Okay, what's the next thing? This doesn't have power? But it is connected. It doesn't... Okay, what if I just... This is actually a pretty challenging PCB for me. So, like, this trace supposedly can do an amp at 5 volts. Okay, so now let's save this and try to reroute it again. frozen. What the hell? It crashed. Great. What's the cost for Oh, so I added all of those. I don't even know why I needed this. How do I make a via? Place via. Place vias. Control Shift. Control X. So what does that mean? So we can go X to here. Okay. I guess not. So I have to go here, Control Shift X, place one of these guys, then go here, then route this to. I don't even understand. But I can't even assign a net to it. Place freestanding vias. Oh, but I think that that's like for like other stuff. I don't think that's what. What? How come I couldn't figure this out? What's left? How do I see what's left? I think we're actually close. I mean, I'm also obviously going to do like 3 more passes of this, but At least we have a route. So we're gonna have to make it like 10 millimeters bigger on each side. Wait, what? That? There's one more. Inspect list unconnected. What's wrong here? What is this error? How do I get the error? Give me the error. I don't know why I did all that. That's kind of weird. What? It's literally connected though. Oh, maybe I just didn't rerun it. Okay, so the main thing though is this needs to be really a beefy trace, but we can do that. We have tons of space for that. So yeah, this all needs to be a beefy trace. What is that? No, these are definitely something. What the freak is that? Oh, you know what? What? What is that? Tracks vias. Is that a via? Pads? What? I don't want to select the pad. What the frick is that? That's the stupidest circle I've ever. I don't know what layer is that on. Comments. Okay, nice, cool guys. I love that. All right, so wait, so vias we need to do vias Control A delete. All right. I wonder if I can route programmatically. I guess I probably can. Because, I mean, do I really want to do this? This is a decoupling capacitor. I don't know how big the traces need to be. That's how big that optocoupler is. That thing is huge. Wait, where's the FET? Oh yeah, okay, so this goes like that, like this. Okay, so Oh, whoa. Whoa. Wait, but why isn't it using it? Oh. What? Hello. Can you get some food? Are you hungry?
Hai vomito, sai che cacca.